So let's do an integration video introduction 2, okay, where there's certain techniques that you need to know, such as if it's x by root of 1 minus x square into dx, linear on the top and quadratic below, so then obviously 1 minus x square can be t, and I'm differentiating minus 2x dx is equal to dt, and x dx will become a dt by 2. So minus 1 by 2 into dt by root t, and you know root x differentiation itself is 1 by 2 root x. So integration of 1 by 2 root x itself will be root x, and we can bring the 2 inside and side 1 by 2 root t, which is root t. So therefore it's minus root t, or minus root of 1 minus x square plus c. Of course you could have done this as t to the power minus half into dt, which is t to the power minus half plus 1 by minus half plus 1, but shortcut is as soon as you see 1 by 2 root t, integration is root t, because differentiation of root t is 1 by 2 root t, and so the reverse of it. Okay. So similarly, I don't have to teach you the other second sum, which is second one can be x by root of 1 plus x square, which will be similar like this, correct? So we don't have to deal with it. You know, in this 1 plus x square is t, is 2x dx is equal to dt, and have x dx. Okay, I'm doing it 1 by 2 into dt by root t, and 1 by 2 root t itself is root t, and root t itself is root of 1 plus x square plus c, and so on. Okay, so the next format is third one, where you have a linear and a biquadratic. So you know you need a quadratic, linear and quadratic, therefore you can write this as x by root of 1 plus x square the whole square. So in this case, if you assume x square as t, 2x into dx will become dt, and then x dx is there, so it's dt by 2 root of 1 plus t square. And root of 1 plus t square is like 1 by root of a square plus x square, and it's a kid's formula, so log of mod of t plus quotient a copy plus c. Log of mod of x plus quotient a copy will become t plus here. What is t here? T is log of mod of x square plus root of 1 plus x square plus c. So that's the answer for this. When it's linear and biquadratic. Similar to this will be fourth sum, which is x by root of 1 minus x to the power 4 dx. Same pattern, x by root of 1 minus x square the whole square into dx. So x square is t, 2x dx will become dt, and x dx will become dt by 2. So 1 by 2 into dt by root of 1 minus t square. So in this case, this is 1 by root of a square minus x square, which is sine inverse of x. It's not log of mod of x plus quotient, it's not kid's formula. So you must remember that, okay. So then sine inverse of t, so half of sine inverse of t plus c, and half of sine inverse of t is x square plus c. So these are the various formats. So what happens when it is x square by root of 1 minus x square, not linear, quadratic and quadratic. Can you see there is a denominator, you have a minus before the x square, so then you can insert a minus before x square, which means you have to insert a minus outside also, so that because minus of minus plus like previous. Add 1, subtract 1 and split it up accordingly like this. 1 minus x square by root of 1 minus x square plus integration of 1 by root of 1 minus x square with both dx here. And this will be root of 1 minus x square. So when you have this minus root of 1 minus x square, this is direct formula. Root of a square minus x square is x by 2 quotient a copy plus a square by 2 into sine inverse of x by a. So this is what I'm going to apply here. But in the case of a, it's just 1 minus of x by 2 quotient a copy plus a square by 2 into sine inverse of x by a, x by 1. So there's a minus which is common for this only, plus this itself is sine inverse of x. You can bring the negative sign inside, it will be x by 2 root of 1 minus x square minus half sine inverse of x plus sine inverse of x, which will be x by 2 into root of 1 minus x square plus half sine inverse of x plus c. That will be the answer for this. So when it's quadratic and quadratic, this is the format we have to adopt. So then sixth one is x square by 1 plus x square. With the root is there, no, don't have to worry, you just have to write a plus and add 1 and subtract 1 and split it up, and so it will become 1 plus x square by root of 1 plus x square minus integration of 1 by root of 1 plus x square into dx. So this will be a root of 1 plus x square into dx, minus this itself will be, this is integration of 1 by root of a square plus x square. A square plus x square is its formula log of mod of x plus quotient A copy, denominator copy plus c. So this is a formula which is root of a square plus x square, which is x by 2 quotient A copy, plus a square by 2, which is 1 by 2 here because a is 1, log of mod of x plus root of 1 plus x square, minus log of mod of x plus root of 1 plus x square from copied from the top. This is half and this is 1, so it will be minus half, similar terms. So x by 2 into root of 1 plus x square minus half log, no, plus half log, right? No, minus half log, because this is plus half and minus 1 log. So minus half log x mod of x plus root of 1 plus x square plus c. So that is the answer for this. So, these are the specific patterns when it's x square by root of 1 minus x square. So, let me tell you something simpler, such as if it's x square and if there's an x cube, then it's just a question of assuming 1 plus x cube itself as t and 3x square dx will become dt, and an x square dx is becoming dt. Can you see the powers moved? So it's very simple. So it's dt by 3, 1 by 3 into dt by t, which is 1 by 3 into log t, which is 1 by 3 into log of what is t is 1 plus x cube plus c. It's that simple, right? Yeah. Okay. Next is, so what happens when it is x square by 1 plus x to the power 6 dx? The previous one is x to the power 3. You can write it as x square by 1 plus x cube the whole square into dx. So in that case you can keep x cube as t, and 3x square dx will become dt, and x square dx is here, which will be dt by 3, 1 by 3 into dt by 1 plus t square, and this itself is tan inverse 1 by a square plus x square, which is tan inverse of x by a, 1 by a tan inverse x by a. So a is 1 here, so 1 by 3 into tan inverse of t, so 1 by 3 into tan inverse of x cube plus c. So that's how you do this. Okay. So now let's look at some trigonometric patterns, such as 1 by 1 plus sin x dx. So in this case I would just rationalize 1 by 1 plus sin x into 1 minus sin x by 1 minus sin x into dx. Denominator will become a square minus b squared, so it's cos square x into 1 minus sin x into dx. Split this up. Whenever there's a single term, you try to always split it up. 1 by cos square x dx minus integration of sin x by cos square x into dx, which is secant square x dx minus secant x tan x dx. So this itself is tan x, this itself is secant x plus c. So this is 1 by 1 plus sin x. Let's go to 10 sum. What happens? 1 by 1 minus sin x, also similar rationalizing. Okay. So 1 by 1 plus cos x dx. Being my student, you will not rationalize this. Of course you can, but you will do it as 2 cos square x by 2. So 1 by 2 into integration of secant square x by 2 dx. And integration of secant square x by 2 is tan x by 2 by x by 2, 1 by 2. Chain rule. So 1 by 2 get cancelled. So tan x by 2 plus c is the answer for this. Okay. So that's all. Is a 10th sum. So 11th sum. Supposing if this 1 by 1 minus cos x means, we'll write it as 2 sin square x by 2, it will become cosecant square x by 2, it will become minus cot x by 2 by 1 by 2. 1 by 2 get cancelled, minus cot x by 2 plus c, that's all. So what happens when it's 1 by 1 plus sin x plus cos x into dx? So somehow I have to convert it as tan. Okay. So that's called the fishing format, where I'll do something so that I'll get a tan and secant square. So that if I assume tan x as t, a secant square x dx will become dt. I need a secant square x. Okay. So then therefore I can write this as 1 by 1 plus 2 tan x by 2 by 1 plus tan square x by 2 plus a 1 minus tan square x by 2 by 1 plus tan square x by 2 into dx. So when you take an LCM, a 1 plus tan square x by 2 will go up. We'll have a 1 plus tan square x by 2 plus 2 tan x by 2 plus 1 minus tan square x by 2. So it will become 1 plus tan square x by 2 secant square x by 2, which is all you wanted that, and you have 1 plus 1, which is 2 plus 2 tan x by 2 dx, so which is secant square x by 2 and 1 by 2 out, 1 plus tan x by 2 into dx. If you assume a 1 plus tan x by 2 itself as t, 1 will become 0, differentiation, secant square x by 2 into 1 by 2 into dx is equal to dt. You have a secant square x by 2 into 1 by 2 itself here. Totally dt by t, which is log t, which is log of 1 plus tan x by 2 mod plus c. So simple as this, okay. So you should remember that you can't rationalize this format. Then what else do we do? You can write it as 2 tan x by 2 by 1 plus tan square x by 2 and 1 minus tan square x by 2 by 1 plus tan square x by 2. Provided there is a 1, that's when you can write it as secant square x by 2 on the top after taking LCM. So that makes this sum very important, okay. And while I taught you 1 by 1 plus sin x, 1 by 1 minus sin x, 1 by 1 plus cos x, 1 by 1 minus cos x, I also should teach you 1 by 1 plus tan x dx, which is the world's most important format, which is 1 by 1 plus sin x by cos x into dx, which will become integration of cos x by a cos x plus sin x into dx. When you do that, you can see what will you think of? You will think of doing a manipulation, okay. So they will think of adding plus sin x and a minus sin x, but it will go on incessantly if you do that. So you must memorize the sum wherein you have to multiply and divide by 2 and then take this as cos x plus cos x and add a sin x here and subtract a sin x here and write the denominator in both the places. Kind of very different weird sum wherein out of the blue you are multiplying dividing by 2, writing the 2 cos x as cos x plus cos x like this and adding and subtracting. So this and this get cancelled, will be 1 dx, and 1 by 2 is common for a whole thing. So this will become integration of 1 dx, which is x plus this will become, whenever you see a sum randomly like this where there is a cos x minus sin x by cos x plus sin x, try to assume denominator as t. It will become minus sin x plus cos x into dx will be dt, and this is exactly that. So it's dt by t. So then therefore it's 1 by 2 into x plus log t and log of mod of cos x plus sin x, well, so t plus c, and you can always bring the 1 by 2 in. So this is the pattern which is very important. They can ask you sums like 1 by 1 plus cot x, they can ask you 1 by 1 minus cot x, whichever is the same pattern, okay, same pattern, and you should remember to multiply and divide by 2, otherwise you're gone, and write it as cos x plus cos x and plus sin x and minus sin x. Literally have to mug up this formats. So let's go to next format, which is the 13th question. Next is all trend fishing formats, wherein when a question is there such as a root tan x by a sin x into cos x, cos x say. The first thing that will strike me is to convert it as tan and secant square, for which I'll write 2 tan x by a sin x into cos x as multiply and divide by cos x, so it will become cos square x dx. This itself will become tan x, and root tan x by tan x will be 1 by root tan x, and 1 by cos square x will become secant square x and go to the top. Now if you assume tan x as t, as secant square x dx will automatically become your dt, so it will be dt by root t, and you know that root x is 1 by 2 root x, and integration of 1 by root x is 2 root x, so 2 root t, so which is 2 into root of tan x plus c. So these are all kind of fishing formats, wherein somehow I will convert the sin and cos in terms of tan and secant square. So then 14th sum, supposing you have a sum like this, which is 1 by sin x into cos cube x dx. Again fishing, I will try fishing, wherein I will try to multiply the denominator, that is what strikes me first, okay. Cos to the power 4, multiply and dividing by cos x, this will become secant to the power 4x by tan x into dx, and you want only secant square x, so write it as secant square x into secant square x dx by a tan x, because this secant square x dx I am going to write it as dt. So I can write the numerator secant square x as 1 plus tan square x by tan x into secant square x. When I do that, I get, if I assume tan x as t, a secant square x dx will automatically become my dt. So then as secant square as dx become dt 1 plus t square by t into dt. Split this up, it's 1 by t into dt plus integration of t into dt. This itself is log t, this itself is t square by 2 plus c, and log of what is t in the sum is tan x plus tan square x by 2 plus c. So that's simple, okay. So next let's go to, this is the 14th question. So let's go to 15th question. What can I say for 15th question? 1 by sin x into cos cube x. Yeah, the most important sum, a very different kind of manipulation will be involved. Okay, before which I'll just teach you this, okay. I think I did sin 2x into cos 3x or whatever. Once again, let me take that question. A sine and cos combination, a combination of sine and cos, okay, very very important sum. 1 second. Yeah. The integration of sine 3x into cos 4x dx. If you have a simply sine 3x you can do, or cos 4x, or with a plus you can do, but no multiplication you can't. So then in that case you have to multiply and divide by 2. And you know where will 2 sin a cos, this resembles 2 sin a cos b, which will be formula for sin a plus b plus sin a minus b. So I'll write this as 1 by 2 into sin 7x plus sin minus x into dx. An integration for both, 1 by 2 is common for both. So 1 by 2 into sin 7x will become on integration minus cos 7x by 7. Plus the sign of minus x is actually minus sin x, minus out, and it will become integration of sin x. Integration of sin x is minus cos x, so it's plus of cos x plus c. So this is how I'll do when there are 2 multiplications, okay. So supposing there are 3 such as cos 2x, cos 4x and cos 6x into dx, I'll just pair it up conveniently. Cos 2x and a cos 6x I'll write together, and a cos 4x I'll keep it separate. Multiplying and dividing by 2 only in this, I'll convert this as, this is 2 cos a cos b format. At 2 cos a cos b will come in cos a plus b plus cos a minus b, which is cos a plus b is cos 8x plus cos a minus b is cos of minus 4x, which is cos 4x, cos of minus theta is cos theta. An integration has not been done, and a cos 4x here. So you have to take the cos 4x now inside. So it will become 1 by 2 into integration of cos 8x into cos 4x plus integration of cos square 4x into dx. So how do we integrate? Now 1 by 2 is common for everything, because first itself you have taken 1 by 2 common. So now in this term you have to multiply and divide it by 2. Multiply and divide it by 2. This is again 2 cos a cos b. So it's 1 by 2 into integration of cos a plus b plus cos a minus b. But this 1 by 2 is also there. Okay, there's a 1 by 2 whole. Only for this term there's a 1 by 2. This 2 is this. Okay. Plus this can be integrated as 1 plus cos double the angle by 2. Whenever you see cos square, it's always 1 plus cos double the angle by 2 using 11th standard formula. So 1 by 2 totally common for everything, and a 1 by 2 is there, and a cos 12x on integration becomes sin 12x by 12, so it becomes 24, plus a cos 4x will become sin 4x by 4 will become 8, plus on this you can take 1 by 2 out, will become x plus sin 8x by 8 plus c, and you can take this inside. So it's 1 by 2 into sin 12x by 24 plus a sin 4x by 8 plus x by 2 plus sin 8x by 16 plus c. So it's as simple as this, okay. There's no like terms, so you've solved fully, okay. So supposing there is a sum, 16 sum is over. So these are the formats you should understand, okay. These are the formats you should understand, and this another important format I want you to learn is this, which is integration of 1 by cos of x minus a into cos of x minus b into dx. So whenever they give you like this, from here it's very high manipulation. You should take minus a plus b, you should write like this. Out of the blue there's a minus a, and here from here you should take plus b and add x and subtract x and take out minus common, so that you will get x minus a into x minus b, the format that is necessary. So this is nothing but a b minus a, right, sin b minus a in other words. So you're going to multiply sin b minus a on the numerator and the denominator, multiplying and dividing by sin b minus a. It will be cos x minus a into cos x minus b. And you just learned that this can be written as this also. The b minus a becomes sin b minus a, which can be added and subtracted like this. So you can also replace, don't replace outside, let it be a constant outside. Here let me bring into sin x minus a minus x minus b format by cos x minus a into cos x minus b, whatever is the denominator, copy. Okay, now this is like sin a minus b, which is sin a cos b minus cos a sin b. So expanding sin x minus a cos x minus b minus cos x minus a sin x minus b by, split the denominator, cos x minus a into cos x minus b by cos x minus a into cos x minus b, dx and a dx. So this is cos x minus b is getting cancelled, cos x minus a is getting cancelled. This is common for everything. 1 by sin b minus a was totally common. And this will become integration of tan x minus a minus integration of tan x minus b, dx and a dx. Integration of tan x is minus log of cos x. So 1 by sin b minus a into minus log of cos x minus a minus log of cos x minus b. Oh, this will become plus because already there is existing minus sign. So this is going to become division because logarithmic subtraction will become division. 1 by sin b minus a into log of cos of x minus b by cos of x minus a plus c is the answer. So world's most important format, wherein it will be like this. So in 18 sum, something very simple I am going to tell you. What happens is 1 by sin square x into cos square x. Then I won't do manipulation in these systems. Okay, I can simply write 1 as, I won't consider it as tan and secant square. I don't have to because it's even power. It's straight away secant square, but there's no tan. So you have to think of writing 1 as sin square x plus cos square x by a sin square x into cos square x into dx. And split this up, it will become 1 by cos square x plus 1 by sin square x into dx and a dx. So this itself is secant square x dx. This itself is cosecant square x dx. So this itself is tan x and this itself is minus cot x plus c is the answer. So there are different ways and different thinking for each and every sum. I hope you all understood whatever I am doing. Okay, so then see, what is important is for you to know that 1 plus cos x is 2 cos square x by 2, 1 minus cos x is 2 sin square x by 2, and a 1 plus sin x is cos x by 2 plus sin x by 2 the whole square, and a 1 minus sin x is cos x by 2 minus sin x by 2 the whole square. Never forget all this. If it's sin 2x, it's cos x plus sin x the whole square, that's all. Okay, and then you all should also know that 2 sin a cos b will come in sin a plus b plus sin a minus b. 2 cos a sin b will come in sin a plus b minus sin a minus b, and 2 cos a cos b will come in cos a plus b plus cos a minus b, and 2 sin a sin b with a minus sign will occur in cos a plus b minus cos a minus b. Supposing there is no minus here, then I will swap this around. It's just simply 2 sin a sin b, right? Cos a minus b minus cos a plus b, that's all. So till here you must become very clear and then finish the 7.2 and 7.3 exercise. Okay.